Hello everyone. This is the recording for the discussion about the functions homework. So we'll talk about the assignment that's due tomorrow on the 25th. So the first thing I'd like to say about functions is that just functions are a very important thing in programming, and especially in MATLAB. You'll see later on just how and why they're so useful and important. But firstly noting that the autograder is slightly different now. So now you don't need to enter the name of your file in the FCN grade command. It finds all the functions automatically as long as you have it saved in the right folder. And the new autograder will give you a score, but won't give you feedback until you specifically ask for it by using the command FCN_feedback. So, question 1 on this homework, it's asking you to take a total number of minutes and convert it to a number of hours and a number of minutes. And then to make a message, which is a character string, which displays in sentence form how many hours and minutes it is equal to. And so the declaration line for this function that you need to write is right here, my time conversion with an input of total minutes and outputs of hours, minutes, and message. So the first thing I would recommend doing is calculating the hours. The rounding functions such as ceiling and floor are one of them, or two of them will probably come in pretty handy here in calculating the hours. And then once you know the number of hours, the number of minutes should be a little bit easier. And to make the message, you want to make sure that you are getting the plurals correct, meaning if there's 1 minute, you say 1 minute, and if they're not minutes, and same goes for hours. So that's about all I have to say for question 1. Question 2, we start with we're making a function called convert with the declaration line shown here. So we have 3 input arguments, a string in, a key, and a mode, and 1 output argument, which is also a string. So the first thing you want to do here is make the key L variable, which is talked about on the assignment sheet. For that, the repmat command is going to be useful, as well as rounding functions. So to encrypt, so I guess the mode here is going to tell us either to encrypt or decrypt, which means that your first input argument, string in, is going to be either a regular string that needs to be encrypted or an encrypted string that needs to be decrypted. So the method to encrypt, if that's what we're doing, is first we use a double command for both key L and string in to convert the characters to their ASCII symbols, which are numbers. And then we add them together and we do some additional addition using a loop for each of the digits. And then afterwards, after you do all the addition, you use the char command to convert it back to a string. The decryption process, if that's what you need to do, is just the opposite of that series of operations. And how do you know if you encrypt or decrypt? That's a good question. So the third argument, if it is there, is mode, is going to tell you if you need to either encrypt or decrypt. So The commands that'll help you are string compare I, which compares entire strings and gives a binary result if they're equal or not. And since we also need to write this function with a default value in case there is no third argument given, nargen is going to be helpful in that one, in determining. So string copy and nargen are both going to be useful in determining whether you encrypt or decrypt. So in question 3, we are doing some very similar things to what we were doing in the loops homework, which is we have strings of ones and zeros, and we are doing things like, for the first one, for example, we have the function outvec equals flip nth. So we have 2 input arguments and 1 output argument. So what we're doing here is we're going through and we're flipping every nth value or every nth thing in the string. Now you can use the code you wrote in the loops homework. There's a good chance you'll have to modify it slightly, either by changing the names of variables or something similar. But the core of it is very similar to what you already did. So don't be afraid to consult work you've already done to help you figure out how to approach these ones. But just remember, they all need to be in function formats. So then the next 2 functions you need to write are flip nth val and find with overlap. And like I was saying, these are similar to the loops homework. And for when you need to set default variable values, you want to again use nargen and some conditional statements based on what is the value of nargen, and that'll tell you if certain input variables are missing, and if they're missing, then you know you need to set them to the default value, right? So for question 4, we're doing some things involving adding polynomials. But first, we're making these functions that are called padRV and onpad. So padRV is going to take some vector and add zeros in front of it, right? So it's essentially taking, if you have 1, 2, 3, 4, it's going to make it 0, 0, 0, however many zeros is specified based on the input arguments, and then just add it to the beginning. So this one should be pretty simple to do that. It's just some concatenation. The zeros command might be helpful. And then the next one is onpad, which is doing more or less the exact opposite of padRV, which takes a string, or takes an array and removes all the leading zeros. Oops. Now keep in mind, if there's a 0 in, for example, this location after all of the leading zeros are gone, you want to leave that there, right? So my hint for how to do that is if you use the find command with 2 input arguments, look that up and look up the help for find and see how to use the find command with 2 input arguments, because that will help you to figure out where there are zeros, and it'll help you to distinguish between what zeros are all at the beginning and what zeros are after the intro, more or less. So then after you write those 2 functions, then you need to write the function polyadd, with an output of psum and an input of p1 and p2, which are both different polynomials. So when you're adding, and these polynomials are going to be, they're just going to be a series of coefficients in descending order, or descending powers, and like described in the PDF file. And remember, to add polynomials, you just add the coefficients for the same powers, right? So if you're adding 3x squared and 4x, the result is 3x squared plus 4x. You don't add the 3 and the 4, right? So to make sure that when you do your addition, that you are adding values in the correct places, you want to first pad your polynomials to add zeros on them, to the front of them, and then once you have the result, unpad them so that the result doesn't have unnecessary leading zeros. And it's also asked of you to do these in the form of local functions. So you're going to take the functions you wrote, and then you're going to more or less duplicate them as local or subfunctions. Now, we haven't talked a lot about local or subfunctions yet. They are, we'll spend more time on them in the next module. But the basics are that they are small helper functions in the same M file as what we call the primary function, which is the one that is named after. So there's one, up to now we've always had one function per M file, and the function in the M file always had the same name. Now, if you use local functions, or subfunctions as they're also called, those are below the primary function, and they do not have the same name as the M file that they're in. So a small example of this is if we had function 1 here, which is the primary function, and then afterwards, remember to use ends for here, and it's not always necessary to use ends for function, but in this case we want to make sure we are using ends to distinguish what's one function and what's the next one. So if we have one primary function here, function 1, and then 2 local functions, one called local function 2 and local function 3 is the other one. So we set this up. Now this is all in the same M file, these 3 things, and it's just that function 1 is on top. So while we're in function 1, we can call the local functions from within the primary function. Like that. So that is about all I had to say on question 4. And question 5 is when MATLAB starts to be fun. In case you were wondering how we use this, you can play games, right? As long as you know how to program them, I guess. So the question here, we're making this game called Medieval MATLAB. And it's basically two players, and each turn, which is represented by one call to the function you're writing, on each turn, each of the two players can pick one of four actions. And also on each turn, each player will have some change in his health and some change in his endurance, right? Based on the combination of actions taken by the two players. So since we have two variables and each one has four potential values, we have two variables and each one has four potential values, and based on what those four are, we end up with 16 possible cases in terms of what the resulting DH1, DE1, DH2, DE2 are. So that would lead to a whole bunch of conditionals in terms of either if-else's or switch cases, but doing that is going to be quite cumbersome, but also unnecessary, since there's a simpler way which is involved with which you do. Sorry. To do this, you take you want to set up an outcome matrix. So basically, think of it like think of this matrix like a picture, just like the one shown on the bottom of page 6 of your assignment sheet, where if each row, if you have 4 rows and 4 columns, each column could represent the decision taken by player 1, and each row could represent the decision taken by player 2. And then for each DH1, DH2, etc., you would have a different 4x4 matrix that says, you know, if player 1 chooses this value, say the second one, and player 2 chooses the third one, say the third one, then it would go to the second column, third row, or second row, third column, depending on which way you defined it. So do the outcome matrices like that, and then you can use the U1, U2 as coordinates to choose which of the values in there is your actual outcome. And now, once you have your outcome, then you need to add an element of randomness in order to make the game a little more interesting, right? So there's a little blurb about that on the bottom of the assignment sheet, but basically, if you have a zero for any one of your values, you're going to do one thing, and if you have anything but a zero, you're going to do a different thing. So if your value is non-zero, you're basically going to multiply it by a random number between 0.85 and 1.15. And if you have a zero, you're going to add to it a random number between negative 0.1 and 0.1. And doing that, remember to use the rands command here. And this will give you a random number between 0 and 1. So you can scale that using different ways. So if you say, for example, like what's given, 2 times so this value, this one as written here, since I subtracted 0.5 from it first, that means that I'm going to be now taking a random number between negative 0.5 and 0.5. And then since I multiplied it by 2, I'm now taking a negative number between negative 1 and 1. So hopefully that doesn't confuse you too much. And of course, you can always come to the lab sessions and ask us about it if it's still confusing to you. But otherwise, I think that's about all I had to say today. Do any of you that are here have any questions? So I guess not. So that's all I had to say about the functions homework. Best of luck, and like I said, don't be afraid to come to the lab sessions to ask us more questions. Hopefully this was enough to at least clear up any confusion about what the assignment is and to get you started. So once again, good luck, and signing off.